Hello, I'm Aaron Zimmerman, and by the end of this video, you will see how to program in Python the calculation that neural networks do. So instead of programming the training of neural networks, we will simply hard code in the values for the network weights and biases. And we will use ChatGPT to help us with our programming. First, we will look at the math, the sigmoid function, and dot multiplication. Then, we will ask ChatGPT to program it and see how it works. The interface starts with a list of floating point values that are normals, meaning decimal values from 0 to 1. Those input values are processed by the neural network, and a list of the same format is the output. The input list length and the output list length can differ. Those list lengths are determined based on the structure of the neural network. Because the input list format is identical to the output list format, we can daisy chain neural networks together in what are called neural network layers. This is the sigmoid function. It's how each individual neuron works. The input that the neuron receives is graphed along the x-axis, and the output the neuron outputs is graphed along the y-axis. Each individual neuron represents a hypothesis, where the output approaches 1 if the hypothesis is true, and the output approaches 0 if the hypothesis is uncertain. If the value that the neuron output approaches 0, that does not mean that the contrapositive to the hypothesis is true. It means that the neuron is uncertain, and so the contrapositive may or may not be true. The sigmoid function has 3 key features. First, if the input value is 0, the output value is 0.5, meaning the neuron is neither uncertain nor the hypothesis is true. Second, as the input gets more and more negative, the neuron outputs a value closer and closer to 0. And as the input value increases, the neuron output gets closer and closer to 1. And third, the neuron output is normalized, meaning the value has to be within the range 0 and 1. In Python, there is no data type that forces this range of 0 and 1, so we simply have to program carefully to make sure those values stay within that range. The reason why the neuron input is unbounded and yet the output is a normal is because the input value is an accumulation of neurons, and furthermore, those values are multiplied by neural network weights, and then a bias is added. In order to understand why we use the sigmoid function instead of any other mathematical function, we can use those 3 key features as our starting point and build the mathematical function as if we are programming with math. First, we want the output to be a normal value, so e to the x prevents any output value from being lower than 0, and 1 over 1 plus e to the x prevents the output from being greater than 1. And that also ensures that the neuron is never 100% sure, that would be a value of 1, and it's never completely uncertain, that would be a value of 0. And now we notice that the output is backwards, so to flip it about the y-axis, we use negative x. So really simply put, if you think of the input list as my hand, where each of my fingers is an individual value, those values are multiplied by the neural network weights using dot multiplication. And the neural network weights is a two-dimensional list, and each of those rows of the list are multiplied by the input list as such. Then those values are added together on a row-by-row basis, and the summation is the output of dot multiplication. That's dot multiplication. Then a list of biases are added to the output of that dot multiplication. Then each of those values with the bias added has the sigmoid function applied to it, and that is the output list. And that's how an individual neural network layer is computed. There can be many numbers of neural network layers. Now that we understand how the calculation for neural networks work, let's ask ChatGPT to program it for us. I'll ask ChatGPT, please write a Python program that computes a neural network with any number of layers from given inputs, weights, and biases. Now, all I have to do to run this code is click Copy Code, Google Run Python Online, click the first result, paste the code in, and click Run. Now, let's look at the code. So here's the sigmoid function, here's the computation function, here are the default inputs, and we're using a random number generator to get those inputs. And here's the computation itself. So we can see in order to do that e to the negative x, there is the numpy library named as numpy, then np dot exp with our negative x value is how we do that e to the x. To calculate the neural network, a for loop is used to iterate over the layers of the network, where np is used for dot multiplication. The output of this will be a list of values that are added to another list. This can be done in Python, and those values will be added on a one-by-one basis. Then, each of those values has the sigmoid function applied to it. This is assigned to the output, which is the input for the next layer of the neural network, and the last output is returned. For homework for this video, you could try to achieve small tasks with neurons that you hard code in. So for example, if you had one input and two outputs, you could try to make the output high and low with a high input, or low high with a low input.